Okay, so we started by seeing random variables. We have continuous and discrete. Let's just remember what this is all about. Random variables are variables that will substitute a long English sentence. So what's the probability that the weight of an animal at the Toronto Zoo is less than 10 kilograms? Well, you will actually call the weight of the animal an X, and that's the random variable. So you will have values assigned to the outcomes of your experiment. So X is just a way that facilitates, or a random variable is a way to facilitate that you put values on the outcomes, such as 1 to heads, 0 for tails, for example. Okay? They can be discrete. They are discrete if they can only assume values that are limited. So they're islands. You can only assume 1, 2, 3, and you can not assume anything in between that range. Okay? That's a discrete random variable, such as a toss of a coin. And the continuous one is something like the weight, the speed, the pH, whatever variable that, if you imagine yourself with a gun and you're shooting the number line, you can land wherever you want. You can land in 200.5354, whatever. Okay? And so because random variables are just a way to substitute long kind of sentences, long things that we're analyzing, long experiments, we can, all the probabilities hold. Everything that we learned about probability will hold, right? So if you would think about this, would be the probability of a mass of an animal at the Toronto Zoo be less than 10 kilos, right? So now you will do just P of X less than 10, okay? Where X is the mass of the animal. All right, so all the laws of probability, they hold, right? So the probability of a sample space is equal to 1. This holds as well. Everything's the same. The independence property also holds. So if you have a random variable X, when you want to know the probability of X given a Y, and if they're independent, Y doesn't change the probability of X, right? So this is the independence property. Everything, all of the properties that independence property. Everything that we saw for midterm 2 will hold in terms of all the rules of probability will hold now for the random variables. Okay? So then we started talking about, particularly about discrete random variables. And we learned how to build what we call a PDF. A PDF, right? PDF stands for probability distribution function. And this function can be shown as a table or as a graph, okay? As a table, we have one column is the values that your random variable can assume. So I'll give you an example here. I don't know. Let me see. Your variable can be 0, 1, 2, 3. And in the other column, you will have the probability of that happening, of your random variable assuming each one of these rows. So what's the probability of your variable being 0? Well, it's 1/8, for example. What's the probability of your random variable being 1? Well, it's 3/8. What's the probability of a random variable being 2? 3/8 as well. And I'm giving you this, right? What's the probability of your X being 3? Well, it's 1/8. Okay? So this is one example of a PDF. And because all the properties of probability still hold, we know that the probability of your random variable being each one of these numbers, the sum of this, okay, so the sum of probabilities of your variable, assuming all the numbers, should sum up to what? It should sum up to 1. Why? Well, because this is the probability of the sample space. The X column here shows all the possible outcomes. So in the end of the day, this column is a sample space, right? So if you sum up all of this, this is the first property of the PDF that we have to remember. So the probability of X being 0 is 1/8. The probability of X being 1 is 3/8. The probability of X being 2 is 3/8. The probability of X being 3 is 1/8. This is 8/8. This is equal to 1. All PDFs has to sum up to 1, okay? And you can see here in the exercise that it's here on the right-hand corner that if you check if this is a PDF, this is 1/9 plus 2/9, this is 3/9, plus 5/9, this is 8/9, plus 1/9, 9/9, which is 1. Okay, so every time, if you're building a PDF or if you're assessing a PDF, it doesn't matter. This column has to sum up to 1. Okay? The other concept that we saw is what we call the CDF. Okay? So it's a third concept here that we're going to call so it's about the discrete random variable, and we have a CDF. Okay? What is a CDF? The name stands for cumulative distribution function, and it is a table, or it could also be a graph, although we didn't see it as a graph, but it could also be a graph, that we show the probability not of your variable being equal to the values in the rows, but to be less than or equal. Okay? So for example, in this example, I have 0, 1, 2, and 3. Okay? And in the right-hand side, in the second column here, what I'm asking is not the probability of being equal to, but the probability of being less than or equal. Okay? So let's reason about this. What's the probability that your X is less than or equal to 0? Okay, so the less than part doesn't exist, right? Because you don't have anything less than 0 here. In the end of the day, the first row will always be the probability of having X equal to 0, okay? Because the other part doesn't exist. So where do you find this information? Well, you find this information in the PDF. So if you look at the PDF here, where my mouse is, you will see that the probability of your variable being 0 is 1/8. So it's just 1/8. Okay? I don't have nothing less than 0, so it's just 1/8. And this is the first property of the CDF, is that the first row is always equal to the first row of the PDF. Okay? It's a property. You will always see it that way. Let's go to the next row. Second row where X is equal to 1. What's the probability of X being less than or equal to 1? Well, the equal part is easy. I can go to the table of I can go to my PDF, right? I can go to the PDF and I can find this value. It's just 3/8, okay? But again, this is not only equal to 1, but it's less than or equal, okay? So I have to sum up the probability of having the value 0. because 0 is less than 1. And that's 1/8, right? So I have to sum up 3/8 plus 1/8. This is 4/8. Okay? All right. Let's continue. The third row is what's the probability of your variable being less than or equal to 2? Well, it's the probability of being 2, which you can find directly on the PDF. So you come here and you find directly on the PDF, it's 3/8. So it's the probability of being 2 plus the probability of being everything less than 2, which is 1 and 0. But you know what? You already accounted for 1 and 0 here. So in the row above. So if you want to do it algorithmically, you just copy the row above. This is kind of the way you automatically do it. You just have the probability of being the number, of being number 2, which is here, plus the row above. Okay? Finally, what's the probability of your x being 3? No, sorry, not being 3. Less or equal to 3. Well, again, you can go to the table. You can look at the probability of being 3. This is it. It's 1/8. Plus the probability of everything above. Well, the probability of everything above is the probability of being less or equal to 2, which is already accounted for in the row that stands above it. So it's 7/8. This is equal to 8/8, which is equal to 1. Okay? The properties of CDFs there are two properties. First of all, it starts equal to the PDF, the first number, and it has to finish in 1. If it does not finish in 1, it's your CDF might be wrong. Okay? Good? Questions about PDFs and CDFs? This is the time. Good? All right. So this is what we saw about discrete random variables. Okay? And we also saw, we saw a fourth item. Let me copy this slide. We saw a fourth item. So I'm going to continue now with the item number 4. Oh no, before we continue with item number 4, we're going to solve this exercise here. The item A of this exercise. Okay? So item A of this exercise is this. Construct the associated cumulative distribution function of x. Okay? So this is a question from 2024. I don't remember if it was from a quiz or for the final. I think it was for the final. I'm not sure. So this question, it gives you the PDF and it asks you to construct the CDF. Okay? So let's solve it here. So that I construct the CDF, I will have my x being -2, 3, 4, and 6. Okay? And here I will show the probability of being less or equal than that. So let's do it algorithmically. The first number of your CDF is equal to the PDF, right? So I will just copy it. It's 1/9. Why? Well, because it's the first number on the PDF. It's here. It's 1/9. What else do we know? As a property, it has to land in 1. Okay, it has to land on 1. And whatever you do to calculate the rows, you have to calculate the probability of being that number plus the row above. So what's the probability of your x being less than 3 or equal to 3? Well, it's the equal to 3, 2 9ths, plus the row above. Okay? This is 3 9ths. What's the probability that your random variable is less than or equal to 4? Well, it's equal to 4, and I can assess that on the PDF. It's 5 9ths plus the probability of everything below that, above that, sorry, which is, if you think about algorithmically, it's just the row, just sum up the row above, which is 3 9ths. So this is 8 9ths. And you can check if you did it right. The probability of being 6 would be 1 9th, right? Plus the row above, which is 8 9ths. So it's 9 over 9, which is equal to 1. Okay? So you can always do like an algorithm, just it's the probability that you can find on the PDF plus the row above. The probability that you can find on the PDF plus the row above, and so on. Okay? Questions? This was worth 1 point. Right? Just doing this was worth 1 point. And it's important for the test that you know how to do it. Okay? It's very important to know how to do a CDF from a given PDF. Okay? All right. So this is what we saw as a CDF, PDFs and CDFs. And then what we saw, and now it's item 4 of our recap, is about creating new variables. Okay? So creating new variables means that you have an original random variable, let's say x, and you can create a new variable by using some kind of formula. 10 plus 2, 10x plus 2. For example, I can create a new variable y, so this is a new random variable, where I construct the new random variable from the old random variable. And in this case is a special type of formula, what we call, like it follows the equation of a line. But it could be anything. It could be 2x squared. It could be 5x plus 3 over 2. Right? Any formula that you're creating a new variable. Okay? Both of these cases here are special. Why? Anyone have an idea of why are both these cases special? Yep. Yeah, because they follow the equation of a line. And the equation of a line is this. Oops, I forgot the x. The equation of a line is y equal to ax plus b, meaning that you have a coefficient, a constant multiplying x, plus a constant b. Okay? So the yellow ones follow that pattern, that equation, while this in the middle doesn't. Well, because in the middle you can see that x is squared, And in an equation like this, the equation of the line, x it comes up just once, right? It doesn't have a square, it doesn't have a cubic, it doesn't have any kind of power, okay? And this one here is also, it follows also this pattern of ax plus b. If you think about just separating the terms, this is 5 over 2 x plus 3 over 2, right? Because you have a common denominator, it's common that you see it like this, like 2 dividing both of the terms at the same time. But it's the same thing, right? So you can see that this here is capital A, it's the coefficient that multiply x, and this here is b. And b can be 0, by the way, okay? Don't forget. If you see only 5 over 2x, this is also in this form here, y equal to ax plus b. Okay? So there's an item b here that, before going to the exercise, let me draw a stop sign here. Because if you have a new variable created by using this special linear line equation, it's actually the correct name is affine transformation, but let's keep it linear. So if you have this, it's really straightforward to find the PDF of this new variable. But if it's not, then be careful. So if not of the form y equal to ax plus b, stop and be careful to calculate the PDF of this new variable. Okay? So let's go to an item B here that I just left it blank. And let's say that I give you this PDF for x, and I say, oh, can you calculate the PDF for a new variable that is 8x plus 2 over 10? Can you find the PDF? Okay, so what we need to do for this item here. So again, I created a new variable from an old one. The PDF for the old one is given, and I'm asked to build the PDF for the new one. So the PDF for y would be, and let me give myself some space here. So PDF for y will be on the left-hand side, on the first column, the values that y can assume, and in the other column, the probability of that being. Okay, the probability of your random variable being, taking on the value of y. Okay? So how do we start doing that? Well, we have to know the values of y. Well, what is the value of y when x is minus 2? Well, I have an equation, right? And just so that you can see it clearly, it's 8x plus 2 over 10. Okay? So what is the value of y? Well, when x is minus 2, y will be the equation evaluated in minus 2. So it will be 8 times, substitute the value of x by minus 2, plus 2 over 10. So this is 8 minus 2 is minus 16, plus 2 is minus 14 over 10 is 1.4. Okay? What's the value of my y when x is 3? Well, again, just evaluate your formula. when x is 3, okay, this is 3 times 8, it's 24 plus 2, 26 over 10. This is 2.6. What's the value when x is 4? Evaluate the formula when x is 4. This is 32 plus 2, 35 over 10. This is 3.4. Oops. The 32 plus 2, 34. 3.4. Okay? And finally, what value y assumes when x is 6? So you just evaluate the formula. Okay? So this is 6 times 8 is 48 plus 2 is 50 over 10. This is 5. Okay? So this is how you do the column in the left column of your problem. Okay. Now, what's the probability? How can I make the probability column? Well, the probability column will be, what's the probability of your y being 1.4? Well, your y is 1.4 when your x is minus 2. And your x is minus 2 with the probability of 1/9. So the probability that y is 1.4 is just 1/9 because it's the same probability because of x being minus 2. Okay? So I just go and I assess the PDF. What's the probability of your y being 2.6? Well, it's just the same thing as x being 3, so it's 2.9. It's here. Okay? And you can take the picture. When the relationship is the ax plus b as this one, okay? This is a direct copy of the PDF. So when this happens, it's just a direct copy. So the new PDF is a direct copy of the old PDF. Okay, not the PDF, the probability, the second column is a direct copy. Okay? Cool. Now, let's do another exercise. It might be that you have a situation in which your relationship is not this way here. It's not y equal to ax plus b. I'm not saying that it will always be different and not a direct copy, but it can be that it's not a direct copy. So every time you see a relationship that is not y equal to ax plus b, just be mindful that you have to pay attention on what you're doing. Okay? So I'm gonna do it in an example. I did this in the other section. I had to change a little bit the PDF. So I'll put it like this. Let me organize this like this is item B, this is item C, then D and E. So item C, so for item C, okay, we're gonna substitute, we're gonna pretend that I'm giving you a new PDF, okay, for items to do item C, just to make the recap. I'm gonna do, it's the same PDF, but I substituted this 3 by 2, okay? It's just an example of what you have to pay attention to. So for item C, just for a minute, until we do item C, just consider that your PDF doesn't have a 3 here, it has a 2. Okay? And let's do the same thing. So now I want a y that is actually 2 2 times squared x squared, okay? And I want you to find the PDF of y. Okay? So I'm creating a new variable, y. I was giving the PDF for the original function, for the original variable. And I want to find the PDF for this newly created y. First of all, when you see that it's 2x squared, if you see something that is not y equal to ax plus b, be careful. You cannot direct copy. It might be that you can, and like if you go reasoning and in the end of the day it's the same thing, good. But it might not be, so you have to be careful what you're doing, okay? So let's do this one. If I want this y, the PDF of this y, I will create a PDF of this new y, okay? And on the y, I have to know what values y can assume. So what value y can assume when x is equal to -2? Well, what should I use? The formula, right? The relationship between x and y. Y will be 2 times x evaluated in -2 squared. Okay? So this is -2 squared is 4. 4 times 2, this is 8. Okay? And I keep going. What value my y assumes when x is equal to 3? So I did this first row, and I'm on the second row here. Well, it will be 2 times 3, not 3, sorry. I'm on the other side, sorry. For item C is this CDF. So I did the first row. Now I'm going to do the second row. So this is 2 times x being 2 squared. Well, what value is this? 2 squared is 4 times 2 is 8. Uh-oh. Should I repeat this line? No. So when you can see that when it's linear, you will never have this situation. When you have, when it's a fine transformation or this line here, this equation of the line, when you have something that is nonlinear, right, you will have, you can have more than 2 results equal, okay? So because this is a PDF, the PDF in its first column, in this left column, it shows all the possibilities. It's the sample space. You have to list your sample space here. You cannot repeat, right? So I won't do this line here. I won't show this line in my PDF. But I have to remind myself that actually I have 2 ways of my y being 8. I have one way is when x is equal to -2, and the other way is when x is equal to +2. Both of this will land in a value y of 8, value 8 for y, okay? All right, so then we keep going. What about this? Well, y will assume 2 times 4 squared. So this is 16 times 2, 32. And finally, in this row here, 2 times 6 squared. 6 times 6 is 36. Times 2, 72. These are the values that my y can assume. Okay? And now we have to find the PDF. I cannot direct copy in this case. So let's reason how it goes. What's the probability of my new created value, variable, take on 8? Take on value 8. Well, it is the probability that x is equal to 2, or x being -2, or x being 2. So I have 2 paths that land me on the y value being 8. So I have to account for both of them. It's the probability of x taking on minus 2, which is 1/9, or, so plus the probability of x being 2, which is 2/9. Okay? So that's why it cannot be a direct copy. There are two ways, there are ambiguity in the PDF. What's the probability of your y being 32? Well, it's the same probability of x being 4, because this only happens when x is 4, so this is 5/9. And finally, there's no ambiguity. What's the probability of your y being 72? It's the same probability of x being 6, because x has to be 6 for your y to value 72. So this is 1/9. Okay? Questions about newly created variables and how to do the PDF. Yeah.
So the B and C questions you added, would those normally be on the test?
Yeah, it could be. It could be. It could be that you are given a PDF, or you find a PDF, and then in one of the items they will ask, so this is a new variable, get the PDF of this new variable. Okay, so it's important to know how to derive the PDF for a new variable. Okay? Great. So now, let's go and discuss item 5 of the recap, which is statistics. Oh no, before statistics, let me just see this. No, yeah, let's go to statistics. So, oops. So let me get rid of this stuff. And we're going to talk about statistics. So item number 5 is, we saw 3 statistics in this course. There are a lot more of statistics, but we saw 3 of them. In statistics. Okay. So what did we see about statistics? Statistic is a measure. You can have different measures that will tell you something about the data. The first statistic that we saw is the expected value, or mean, or average. Expected value is more formal. And the concept of expected value is this. The way you calculate is you take the values of that your variable can assume, you multiply them by the probability of that happening, and you do that for all the rows and sum them up. Okay? So this symbol here is this sum symbol. So in this case here of the question, item C says determine the expected value. Okay? So let's determine the expected value. This is item C. I'm going to solve it here. Let me solve it here. So the expected value of that x, of that random variable x, will be the little values, the values that the x can assume. So minus 2 times the probability of being minus 2, which is 1/9. Do this for all rows and sum them up. So plus, the second row is 3 times 2/9 plus 4 times 5/9 plus 6 times 1/9. Okay? So this is this is how you calculate the expected value. It's just multiply all the rows and then sum the multiplication up. Okay? If this is an open question, you can leave it like this. But if it's a multiple choice, maybe you will have to work this around. It's not that difficult. Everyone has the same denominator. So minus 2 plus 6, that's 4. Plus 4 times 5 is 20, that's 24. Plus 6 times 1 is 6. 24 plus 6 is 30. So this is 39ths. This is the answer. Okay? Yeah.
So does the graph always have to be a PDF to do this one?
You can be given a histogram, which I don't think it will be, but as we saw, this is good as a recap as well. We can show the PDF as a graph, right? So you can take on values minus 2, 3, 4, and 6, and you will have, this is 1/9, 2/9, 5/9, and the other one is 1/9. So you could have this this kind of graph, and the area will be given to you. You could be given this as well, like this. This is the area, okay? It's not the height, it's the area. Okay? But you always have to have like the values that your variable can assume times the probability of that being. Okay? All right, so the other statistics that we saw was variance. So we saw variance. And the way that we count, before going to variance, let's just recap what the expected value means. So this 30 over 9 is 3.33333, right? So this is somewhere here. Oh, Jesus. This is somewhere here. I don't know. I'm doing it by eye. And what this value means? Well, think about the mean as a scale that is weighting on the likelihoods. So you can see that it's this here is equal to this, so they're kind of balanced. But this one, and let me do it. So this is 3.5. Yeah. So it's somewhere near here. But this one is bigger than that, so the mean is pushed a little bit to the right because it's a scale, right? So think about this as being cement blocks, and you have a scale. Your scale won't be in the middle because this part is bigger than this, so it will push the line a little bit to the right. Okay? Yeah.
So if you get 30 out of 9, how do you translate that to fit into the histogram?
To fit in the histogram?
Yeah, because like 30, doesn't that like go above all of it?
So 30 over 9 is something, it's approximately this.
Okay.
Right? So I'm putting this number here, 3.3. Okay? So this is where the scale, if you had the scale that with the pointer, that's where it would stop, because it's kind of weighting both all likelihoods. Okay? All right, so now we are going to see the other two statistics. We have variance and then standard deviation. So there are two formulas to calculate variance. The first formula is, the way to calculate it is the expected value of a new variable. And this new variable is given by this. Squared. Okay? So this is this is one of the formulas that you can calculate variance. You take your variable x, you form a new variable, which is x minus mu squared, and you take the expected value of that. And the other formula that you can calculate variance is e to the it's e of x squared minus mu squared. Okay? So there are two formulas, two different ways that you can calculate. Usually when you're given a PDF, it's better to do this one. Okay? But it's not, you don't need to. You can do, it's actually, some cases they're the same work, right? So you can go for whatever you like best, okay? So in this case of our exercise, and just to recap, what does variance mean? Variance mean how spread is your, let's determine, so item D. So let's determine the variance of x. Okay, and I'm going to use the first formula. You can repeat this at home if you want with the second formula. In OWL, with the videos I uploaded on the formulas, I used the second one on 2 exercises, so you can take a look at that as well. Okay, but now we're going to use the first one. So what am I going to do? The variance is the expected value of a new variable. Okay? And so you could call it W if you want. You could call it capital W is x minus mu squared. So this new variable here that I'm putting in yellow is what I'm calling W, right? And I have to find the expected value of that. What do I need to find expected value? I need the PDF, right? So that I can multiply the columns, that I can multiply this, okay? So what I'm going to do is I'm going to find the PDF for W. So this is little w, and this is the probability of W being little w. Okay? So what is the value that your newly created variable takes on if x is minus 2? Well, and I'll do this all these calculations. In the test, the numbers will be more friendly, okay? If they ask the variance, the numbers will be more friendly, okay? So this is minus 2. Let's get the numbers on the formula. When x is minus 2, this is minus 2 minus the mean, 3.33 squared. Okay? So this is minus 5.33 squared. And I did this calculation. This is 28. Okay? Then 3. When x is 3, this will be 3. W will be 3 minus 3.33 squared. This is 0.33 squared, or 0.3 squared, 0.03 squared. This will be 0.09. Okay. Then what happens when x is 4? You will have 4 minus the mean, 3.33 squared. This is 1.33 squared. I did this calculation, and this is 1.69. And finally, when x is 6, this is 6 minus 3.33, right? This is squared. Don't forget the squared is 729. In the test, these values will be easy to do, okay? It's just that the question in the test was like here, and I just augmented it to calculate the variance, okay? Don't be scared. You won't have to kind of do squared of 1.33. You won't have to do that. It will be easier, okay? Good? So this is W. This is the newly created variable. I'm doing the PDF, again, recapping. I'm doing the PDF of this yellow variable so that I can calculate the expected value. So let's go with the probability. What's the probability that my W is 28? Well, for my W to be 28, I need X to be minus 2. So that's 1/9. And I don't have any, see, this is a nonlinear relationship, and it will be a direct copy. It can happen, but in other cases it can't. So this will be a direct copy because I don't have ambiguity. So the probability of W being 28 will only happen when X is minus 2, so the probability is 1/9. Probability of being 009 is when X is 3, and that's 2/9. So it's a direct copy, 5/9 and 1/9. Okay? Is this the answer? No, it's not. What do we need? We need to calculate the expected value of this. This is the expected value of this. Okay? So the variance is the expected value of this W. How can I calculate the expected value? Well, if you have the PDF, in this case we did it, just take the values that your variable can assume times the probability. And do that for all rows and sum them up. So 28 times 1/9, 009 times 2/9, plus 169 times 5/9, plus 729 times 1/9. Okay? So, important information. If you want to calculate a variance, you will have to find the PDF of a new variable. The variable in yellow. You can name it whatever you want. You can name it W, you can name it Y, you can name it not Z, but you can name it whatever you want. And find the PDF of this new variable, and then calculate the expected value of the new PDF. That's the way you calculate variance. Okay? If you want to use the second formula, it's fine. The way you should do it is you would create the W would be X squared. So your new variable will be X squared. You would have the PDF for X squared. You will calculate the expected value of X squared, but then you would have to, from the result, take the mean squared out of it. You subtract the mean squared. Okay? In terms of work, I would say it's similar. I tend to like more this one when I'm giving the PDF, but it's up to you. Okay? Yeah.
So what's the answer for the variance?
This, and I'm not calculating it. It's not simplifying it because the numbers are not pretty. But if it was an open question, you could just leave it like this. So like variance of X is equal to 28 times 1/9 plus 009 times 2/9 plus 169 times 5/9 plus 729 plus times 1/9. Okay, so it's exactly the expected value of this new created variable. Okay? Questions about variance of this mean, expected value of discrete variables, how newly created variables, how to do the PDF. We're good? Okay. So before we stop, I want to continue the recap on item 6. So this is item 6, okay? And item 6 is the binomial random variable. Okay, so if you recall from midterm 2, we could do experiments where we repeat. It was called repeated trials, right? So let's say that I'm doing an experiment with repeated trials. For example, I'm tossing a coin 5 times. So I'm doing 5 repeated trials. And for me, success is having a heads, okay? It could be different, but let's consider that the success is having a heads. I could have 0 successes, meaning that I had 0 heads in 5 trials. That could happen. I can have 1 head on the 5 chances that I take. I can have 2. I can have 3, 4, and 5, right? So I could create a PDF to this random variable that is the number of successes on a repeated trial, okay? In this case, the number of heads. Number of heads in 5 trials. It could be 0, it could be 1, it could be 2, it could be 3, it could be 4, okay? If you recall, how do I calculate probabilities of repeated trials? It's using the binomial notation. Okay, so just to recap, the probability that I have 0 heads is get 5 trials, choose 0 to be successful, to be heads, times the probability of heads, and let's say that this is an unfair coin, okay? This probability of heads will appear 0 times, because I have 0 successes, and the rest, the probability of the other thing, which is 1 minus 0.6, have to appear 5 times. Do you remember this? This is called the binomial, the repeated trials binomial notation, okay? So if I were to construct this PDF, I would go and calculate now the second row. Oh, 1 success, meaning 1 heads turned up. What's the probability of that happening? It's given by this formula. I take 5 trials and choose 1 to be heads, to be successful, times the probability of success appearing 1 time, and the probability of failure, or tails in this case, appearing the rest. So if 1 is heads, I had 4 being tails. Do you remember this? So I could go on in this PDF, right? And we saw in the end of the course that if this kinds of binomial discrete random variables, if we repeat lots and lots of trials and you do a histogram, so if you do the PDF in graph form, you will have a PDF that resembles a normal distribution. Okay, and it will always resemble a normal distribution, okay? All right. So this is kind of a recap of what is the binomial random variable. Okay, so it's a repeated trial where you have a chance of success and you want to assess the number of successes, the chances of having the successes, okay? Now, it's so common in science, engineering, and even in psychology, where you're going to do trials. It's so common. This thing comes up so common that they changed the notation. They created a notation, in a special notation for this variable x, and the special notation is this. This x that was the number of successes. The number of successes, I don't know how to write successes, number of successes on n trials, okay, you will they call this a stylished B, okay, for binomial, but they overload the x. The x is now it's B, and this B is overloaded with some information under between parentheses. The first information is the number of trials. It's n. And the second information is the chance of success. Okay? So in our case, this x here, we could substitute this x by a binomial in 5 trials with a chance of heads, which are my successes now, which I'm considering my success, of 0.6. Okay, so it's just a notation. And we have to know what the notation kinds of brings us in parentheses. Is the information of the notation. Okay, so in the end of the day, the way this PDF shows itself, it's not the probability of x, it's the probability of this stylish to be of 5 with a chance of 0.6 being equal to what we call a k. It's the number of success. 0, 1, 2, 3, 4, 5. Okay? It's the same thing. It's just the way you see the notation. The notation won't be P of x. Because it's a binomial trial, you will see this stylish to be. Okay? So let's do this exercise here. A bag contains marbles of 2 different colors, where 1 out of 13 is red. Okay, so I have a bucket, a bag. I have, red, and I have blue balls. I don't know how much of these balls I have, but I know that the probability that I draw red is 1 over 13. Okay? This is the information that I was told. What is the random variable that represents the number of times a red marble is drawn? So this is the first. This question, it was A and B. I just kind of, when I copied, I screwed it. Okay. So this is question A. Okay. So A, what is the random variable that represents the number of times a red marble is drawn? Well, first of all, let's read. You will repeat the process. So a marble is drawn and replaced, and the process is repeated 23 times. This is very important information. You're repeating the trial 23 times, and the marble is replaced, meaning that repeated trials, if you remember what's a repeated trial, is you have options. For the first trial, for example, heads and tails. For the second trial, you need to have the same options, heads and tails, right? And so on. So the fact that the guy replaced the marble is good, because in the second, let's say that you had blue and red. If the guy didn't replace the red, in the second trial, you wouldn't have that option, okay? You would have different options. So the probability of having that option would change. So this is important. If he replaced the marble, that's a repeated trial. That's a binomial random variable. So A, what is the random variable that represents the number of times a red marble is drawn? It's just the random variable. Well, it's a binomial random variable in 23 trials with a chance of success, and red is the success, 1 over 13. That's the answer. Okay? This was worth 1 mark. It's just putting on the symbol, like the notation. Okay? Any questions on the notation? that 23 is the number of trials, P is the number of successes. P is the probability of success. Okay? Now, item B, it says like this. What is the probability that you draw 3 red marbles within 23 trials? Okay? So what I want now is the probability of that random variable that I just found equals to how much? To 3, right? Remember, the variable is the number of successes, and I want 3 red marbles, so I want three trials, okay? If I had the PDF like exposed to me, I just go to the line where I have 3 successes, and I would retrieve the figure there, okay? But I don't have it. They didn't give it to me. And they didn't give it to me because they want you to calculate. And we know how to calculate from midterm 2. Remember, the test will cover midterm 2, 1, and the final content. So they will mix up some questions. So this is the probability of this binomial variable being equal to 3. I don't have it explicitly, but I know that this is a repeated trial where you will have to take 23 trials, choose 3 to be successful. The probability of being successful you were given have to appear 3 times. And the probability of not being successful, which is 1 minus that, which is 12 over 13, have to appear the rest. So, it's 23, right? So it's 20 times 23. And this will have to appear 20 times. And this was worth 2 marks. This exercise was worth 3 marks. Okay? Questions about calculating this probability of the binomial random variable? It's good? All right, so we will leave it here. Let's continue next Thursday. We will have four exercises or 5 and finish our recap. Thank you so much, guys.